In this video, we're going to dive a little bit deeper into how to show profit maximization in a graph. We're going to base it on what was going on in that Cohen and Tabarrok video, but we're going to make this graph a lot bigger. And we'll start off with those cost curves. So that here's our U-shaped average total cost curve. And we'll put a check mark shaped marginal cost curve. And even though it's not included in the Cohen and Tabarrok video, I'm just going to go ahead and include another important curve that we're going to get to later called the average variable cost curve. We explored the math of these in a previous lesson, but I just wanted to remind you that the T here, the average total cost curve, one way you can remember which curve goes on top is T for top, right? And the reason why it's on top is that this curve includes fixed costs, but this curve does not include fixed costs. That's why it's smaller at every possible point than the average total cost curve. Okay, so now we have our cost curves, marginal cost, average total cost, and average variable cost. Let's include a marginal revenue curve. So let's say the price of this good is $50. Okay? And because this firm is in a perfectly competitive market, that means that no matter how much they produce, they will always get a price of $50. That means that their marginal revenue curve is also equal to $50. In fact, this firm's demand curve is that price. So the individual firm's demand is that price. In fact, sometimes if you look up different lectures for high school students, sometimes this is called Mr. DARP. So marginal revenue is equal to demand is equal to average revenue is equal to price. So it's a little bit goofy, but it does help you remember it. Okay, so we've got our marginal revenue curve and our firm's demand curve and our price. And remember that the profit maximization rule is to choose the quantity where the marginal revenue of that quantity is equal to the marginal cost of that quantity. Visually, that is where those two curves intersect. So let's keep track of that. That is our profit maximizing quantity. And the price is just, well, it's the market price. We can't control it at all. Now, in the video, they pointed out that we can see this visually on the graph pretty easily. So profit is equal to price minus average total cost, and all of that multiplied by your quantity. So we can see this visually as this is our price, right? So that's our price. This is the average total cost of that quantity, which I believe in that video was $25.75. So our price is $50. Our average total cost is $25.75. And the quantity in the video was 8 units. So we could easily solve for that with a calculator, which I believe turns out to be $194. Now, I want to point out something here to you. The area of a rectangle is the height times the width, if you remember that from long ago. And if you look here, this is a rectangle. And we can see this rectangle in this formula here. This is our height, and this is our width. The width is the quantity, and the height is the difference between the price and the cost per unit. So this shaded area here, this is the area of profit, in a graph, which is just the difference between the price that the seller can get, how much it costs per unit to produce, times the quantity that they were producing. So let's take a moment to practice doing this in a more generalized, kind of a back of the envelope rough sketch. So if you didn't know what prices and quantities were, you want to just illustrate what profit maximization looks like in a graph. You would take those marginal cost curve, average total cost, marginal cost, and then marginal revenue. Let's just make him a Mr. Darp while we're at it. You would find the first step once you've drawn your curves is to first find your profit maximizing quantity. That's always going to be where marginal cost intersects your marginal revenue curve. That's the quantity where those two values are equal to each other. And we know from the profit maximizing rule, right? This is a rule, it's always true. Marginal revenue will always equal marginal cost at the profit maximizing quantity. So even without calculus, we can still manage quite well, thank you. Then, once you found the profit maximizing quantity, and you know what the price is, you can then find the area of profit. You find the difference between that price and your average total cost curve, and the cost per unit for that quantity. So this area here would represent your profit. Now that we know how to sketch that out, let's revisit the idea of a firm producing at a loss. So again, let's start with our cost curves. Quantity, dollar, or price, and the same thing in this market. Average total cost, marginal cost, and then let's use marginal revenue down here. Now notice that this marginal revenue curve lies completely below the average total cost curve. That means there is not a single quantity that would ever make this firm a positive economic profit. In a later video, we're going to talk about why a firm would want to do such a weird sounding thing, but right now we're just trying to find out what their best option is, right? If there's no quantity that's ever going to make them a profit, what's their best choice? Well, that best choice is always to produce where marginal revenue is equal to marginal cost, right? So that profit maximizing rule is the same as a loss minimizing rule. So even if they're not making a profit, this is choosing the smallest possible loss. So again, we find the profit maximizing quantity, then we go up to the average total cost curve. Right? So this tells us what the cost per unit is for that quantity. That's our price. And the difference between the price and the average total cost multiplied by the quantity produced gives us an area of profit, but this is going to be negative profit. In other words, this is a loss. So that rectangle represents this firm's losses.